proving trig identities, your first sentence that I put here is, you must prove using the left side and right side separately. The first step should never ever be moving anything from the left side to the right side. Keep the original left side and right side and conclude with the left side equals right side. There was other ways of concluding it in high school. I think they just do left side, right side. We used to do QED or a little square box and stuff, but we'll just do left side equals right side, so make sure you write that. More than one solution is possible because there's going to be different ways that you can get to the answer. What we're hoping for is that you're getting to your answer in a nice way. If you are, for instance, taking, this is a slight exaggeration, but taking 20 steps and it should have been 5 steps to get there, I may take off some marks, because what probably happened, if you're taking 20 steps to get to something that someone else is taking 5, you're probably going around in a circle. Right? You're taking something, switching it, going back and forth. So when you look at your answer, it's not just the answer, it's kind of how you get there as well. You're trying to look for a good way to get there. Okay, so if it is a method where you went around in a circle and you're going back and forth, and finally you got there, I still might take off a mark or something, right? Just because it might have been like the worst possible way. It's like you went around in a circle 4 times and you came back to the same thing, and then you finally got it. It's good you got there, but you also want to get there in a better way, okay? Usually that doesn't happen, but once in a while I go and I say, yes, you got to the answer, but look how you went in a circle over and over again, okay? We will look at more than one solution for each question if we can, okay? So on some of the questions, I'll be like, let's try it a different way, and space permitting as well. To disprove an identity, you need only to give one example when it's untrue. Whenever you're disproving something and you want to say this doesn't equal, if you put in a value and left side doesn't equal right side, to disprove something, it's the easiest thing. You just say it didn't work once. To show something doesn't work, you just have to show me one time where that didn't work. So right, if I say that no one is allowed in this room unless they're wearing boots, I can look over and go, you're not wearing boots, too late, your rule is gone, right? So you go, no, your rule didn't hold true, right? So as soon as you disprove it one time, it's no longer an equal, right? It's no longer a set rule and identity. But to prove something, you must prove in all cases. So we're going to prove this. So we have to prove without subbing in any values and without, right, actually calculating anything. So let's look at the first one. We have 1 plus tan and 1 plus cotangent equals tan theta. The first step for these ones, I know it's a pain in the neck, is to just break it apart. So take your left side and the right side and just write it down really quickly. So we're going to go left side equals 1 plus tan theta and 1 plus cotangent theta. And my right side, you can write it anywhere. I'll just write it to the side here, equals tan theta. Okay, so I do want you to write the left and the right side down, please. Right, and I know it's a pain, but you're setting up your stage. It's basically your title for this. So don't start right into the equations. So I do want you to write that first. I know it's a pain, but you're setting up the stage. You're saying, this is my left, this is my right. I separated it from the question. Not yet, later. Right, so we got this. Then what we're going to do is, now how many people started with changing it to sine over cos? How many people did not and kept it tan? Because we trained you well in grade 11. So in grade 11, we kept saying, change it to sine cos, change it to sine and cos. That is a great method. Perfectly wonderful. Let's do it first. So let's do that method, which was your first instinct, right? Then I'm going to tell you to look back at it one more time. Okay, so let's do this way here. So we change it to sine over cos. We get 1 plus, and you go sine over cos, right? I like to write it horizontally. You don't have to, only because I think it's just, I find it neater. So I do divided by, and I do 1 plus, and this will be cos over sine, like that. Okay, so then we did lowest common, probably, yes? Lowest common would be next instinct whenever we said, oh, and also wait, let me point out, if you're going to do this where you change this numerator here, so what I did is I went, the numerator is here, like that, right? And then denominator is here, which is here, right? So I did that. If you're going to do that, I need you must put the numerator in a bracket and the denominator in a bracket, like that. Okay, it has to be done in a bracket. Otherwise, you're saying something different mathematically, right? You're saying all of the numerator divided by all of the denominator. So it must be in a bracket. Has to have that bracket. right? So brackets. Brackets. Okay, has to, not negotiable. Okay, that will definitely be marked off if you don't do it. It means something totally different mathematically because there's two terms. And the reason why I need the brackets is because, look, the two terms are divided by the two terms. Okay, then lowest common denominators. We're going to do over 1, over 1. This one would be cos, and this one's sine. You don't have to show me that. If on the next line, I can read it, and it will go cos theta plus sine theta all over cos theta. Yeah. And then divided by, and this would be sine theta plus cos theta over sine theta. Good? Okay. Division becomes multiplication, and then reciprocal of the one after. So we're working with fractions. So this will become multiplication. So keep the first one as is, cos theta plus sine theta over cos theta times, and then we want the reciprocal, right? So the reciprocal this side, you don't have to show these arrows just for your notes. We went sine theta over sine theta plus cos theta. Okay. Now, you are only allowed to cancel a binomial with a binomial and a monomial with a monomial, just like we have been doing since grade 11. You are not allowed to ever cancel this. Sorry, my thetas get messy. Okay? You are never allowed to cancel that. Does that make sense? You're not allowed to sine theta over sine theta plus cos theta. I get a lot of people who do this. That is not allowed. This is a binomial. It's the whole thing. So that's like saying if I had 2 over 2 plus 3, can I cancel the 2's? No, that makes 0 sense to you, right? When you put a number in, you go, why would I cancel the 2? This is supposed to be 2 over 5. I don't cancel it and make it 1 over 3. That makes 0 sense. It's the same thing with the variable. You cannot cancel it. If it's just this, so if I had sine theta over sine theta cos theta, that is okay, because you can cancel those guys. That's the same thing as saying 2 over 2 times 3. If you cancel that, that's 1 over 3, which is the same thing as 2 over 6, right? So that's okay. Multiplication works, not addition or subtraction. So if this is a monomial, you're good to go. If it's a binomial, you cannot. As soon as there's a plus or minus, you cannot cancel half of it. Okay, cannot cancel half. Does that make sense? All right, so don't do silly mistakes like that when we're doing variables. These are same thing, variables. So you cannot cancel, but I can cancel, hall pass. Thank you. Okay, I can cancel the whole thing with the whole thing. The whole binomial with the whole binomial. Never monomials with binomials. Clear, right? You get mixed up just because of the sine cos. You're so focused on that, you forget the rules. So good, that those two full things can go. Cos plus sine and sine plus cos are the same. That's like saying x plus y is y plus x, right? Those are the same things, so you can cancel those guys out. X plus y and y plus x. Okay, so then I write down what's left over, and it's sine over cos. Sine over cos is, I want you to stop when the left side and the right side are equal. So either change this one to sine cos or change this one to tan. But I need you to stop when both of them are identical. Not when they're close, they're really, really close, but totally identical. So either switch this one to tan, or I could have switched this one to sine over cos. And then you go, therefore, left side equals right side, and you've proven what you needed to prove. Yes? Is there a way to solve this by keeping it in terms of tan? That's exactly what I wanted to show you. So that's why I asked you. So the question is, can we keep it in terms of tan? Please do. Try. So this I would still mark okay, that's fine. However, I want you to look at this with more of a grade 12 eye. So in grade 11 we said sine cos, sine cos, sine cos, just keep going, you'll break it down. I want you to look at the question one more time with me. So this is beautiful, it's fine, it's wonderful. However, as my professors would say, it's not as eloquent. We want a beautiful solution. We don't want a solution, we want it to be pretty, nice. They wouldn't say pretty, but eloquent. That's an eloquent way to put it, right? So you want it to be a little bit more concise, worked out, using the better method. So take a look at your question one more time. So I'm going to take my left side. So I'm going to say or, Left side is 1 plus tan theta and 1 plus cotangent theta. My right side, again, is just tan theta. So I'm starting the question over again. We're going to do this in a more eloquent way. Gorgeous, gorgeous. So beautiful up here. Nice, nice. Let's move that off. Pretend we're starting it all the way over. Okay, so let's start it again. Take a look at the question. It is all tan and cotangent. Nothing else is happening, right? Nothing else is happening, just tan and cotangent. So rather than switching everything to sine and cosine to make it the equal, let's change cotangent to 1 over tan. It's a better way, so I'm hoping that you'll look for these ways as well. So I'm going to leave this 1 plus tan divided by 1 plus 1 over tan. So just change cotangent to tan. And the reason why, again, look, it's tan, tan, and cotangent is tan, which is much nicer. Then you can still do lowest common, which would be tan. Which would be tan. So then we're going to go 1 plus tan divided by, and you're going to get tan theta plus 1 over tan theta. All right. Division becomes multiplication. If you want to skip this step and change division to multiplication and flip it all at once, you can, right? And again, in grade 12, then you're more used to doing this. So you might have skipped this step. You might have skipped it and gone straight to this, which is totally fine. So this will be 1 plus tan theta times, you don't have to use the time symbol, you can use the bracket, but it'll be tan theta over tan theta plus 1. So that, and again, you don't have to show the over 1, but look, 1 plus tan and tan plus 1 are the same thing, right? Those are the same binomial, 1 plus tan and tan plus 1, so I can cancel them, and look, I'm left with tan. Still 4 steps. The other one wasn't too many more steps. It's not the number of steps, it's the way you're going about the steps. Right? So it's not just the sheer number of steps, it's the way you're doing the steps, right? The way the steps are being worked. So here, look how much simpler that is. It's all in terms of tan. You didn't have to do 2 lowest common denominators. It's much prettier. So, but it is. It really is, right? So it's kind of like look to see if what you're solving for is kind of the best way. I would still accept both ways. That's fine, except this one is a little bit nicer. Okay. Good? Right, so taking a grade 11 question, we did the exact same question in grade 11, but now you can hopefully look at it in maybe 2 ways, right? Because now it's your second time doing it. Now let's try B. Any other questions with that one? Okay. Let me try B with you. This is going to be fun. Now, it's our first one where, sorry, I'm just putting lines. It's our first one where we've got double angles. How do you know when to use double angles? When it says 2x. Maybe. Maybe. Hold on. Hold on. Not always. Okay? But again, it's going to be this idea where is there a better way to do it? We'll get to one of those. In this case here, what I do is I analyze it and I go, ooh, double angles. So you'll know when to use the new angle formulas, the compound and the double angles, because it'll be pretty obvious. Look, 2x. There's the possibility of using the double angle formula. Now I look to the other side. The other side is giving you clues. Because this is x, and that's 2x, I do want everything to be broken down to x's. If they're both 2x, then it's going to be like this scenario where just leave it. Then the angle is 2x. Leave the angle as 2x. So that was this case. Here it's not. It's 2x's mixed with x's, so I do want to break everything down to a single angle. Okay, so I don't want double angles, I want x angles. All right, so I look and I compare and I go, definitely want to break that down. Now, let's copy down the question. I know copying down the question is a pain. I still want you to do it. All right, so it's just kind of, it's like a title. Okay, so no matter what, it's like a little bit of a title. It's a little bit more picky on my part, but let's title it. Okay, and then my right side is tan x. I'm just going to leave this to the side because I don't think I'll need it very much because I start, right, from last year we start with the more complicated side. Sometimes we have to work both sides, but this time that's way simpler, so I'll start with this. It's telling me to get down to a single angle though. So if I have a double angle, there's only one choice I have with sine of sine 2x. There's only one way I can write it, so I'm going to do sine x cos x. There's only one way.
Wait, should we get the formula sheet for this test too?
You get that exact same formula sheet. So it will not have Pythagorean identity on it. So yes, which formulas will you get? It's the one where, yeah, so you'll get this one on the evaluation. Unless you refuse it. You can say, you know what? I don't want it. Instead, take it off mine. I told you, I used to have to memorize these. We sounded like crazy people. We were in the hallway going, so cosine, and you just sat there mumbling these formulas yourself, and then walked in, grabbed the sheet, and wrote down furiously for 5 minutes without looking up, and just wrote down all your formulas. And then you were good to go. But yes, we will generously give you this. You can just refuse it. Just don't. Okay, but yeah, so they'll be on here. Like I said before, I still want you to be able to recognize it, and you'll see why. We're going to get to some questions where you have to be able to recognize it, be able to go back and forth. Okay, so you'll get this exact one. You'll notice there's no Pythagorean, right? In the reciprocals, you should know. Okay, now, here, we've got this one, so we know it's 2 sine cos. Here, it's 1 plus cos 2x. For cos 2x, we know that there are 3 choices, right? You should know that. So it's going to be 1 plus. I have my choice for cos 2x. Again, you should know the 3 choices. The 3 choices are cos squared minus sine squared, 2 cos squared. The way I memorize that is the cos squared goes first because it's more important. So 2 cos squared minus 1 or 1 minus 2 cos squared. Here they are in case you forgot. So it's cos squared, sine squared, cos squared first, and look, the only one where sine squared is second is when, because it's the second one, because it's the second version, and that's cos and that's sine. I always think cos goes first. Cos, then sine. Okay. So again, you don't have to memorize it, but recognize it. So I have my choice. You can use any of them, you'll get to the right answer. Which would be the better one to choose? Think in terms of that.
Squared minus 1.
-1. How come?
You can get rid of 1.
Yeah, I have a 1 plus. So if you plan ahead and go use this one, these guys here, oops, this one and this one, +1, -1 cancels to be gone, 0, right? So yes, any of them will work, 1, 2, 3. This one saves you steps in the long run. So try to use this one because I have a 1 plus and -1 is going to cancel that out. And then it just saves you more work at the end. Okay, so that's why. So there's a better way sometimes and a not better way. So definitely choose that one. Okay, so that cancels these guys out. 1 minus 1 is 0, gone. I'm going to rewrite it just so I can picture what's happening. So we're going to go 2 sine x cos x over 2 cos squared. Oh, shoot, I switched it to theta here. Sorry. I was copying from the examples. Yes, you should make sure you copy down the right angle. Okay, you're reading your stuff over, so you'll be able to, yeah, so don't switch from thetas to x's like I just did, so I noticed it right away. Fix it. All right. This is a monomial, right, because it's all multiplication, and that is a monomial, it's all multiplication. So that's where you can cancel. Binomials, you can't. Like if it's a binomial with a monomial, no, but yes, you can cancel here. So I can definitely cancel the 2's to make it 1, and 1 of the coses to make it a single cos. Then you're left with sine, and you can keep looking, you're like, yes, there you go, which is 10. So stop when they're identical. There we go. Okay, good. So that's why I mean that you choose a better way rather than just a way. Any questions with that one?